Hello. Whew. Okay, that works. Hello, Madrid. I am Kenneth Hansen. We are here with Jeffrey Snower, Distinguished Engineer, to talk to you about desired state configuration in PowerShell. It's been a little while coming for us. We're pretty excited to go tell you about it. We think it's the next, great innovation. It's the funnest thing I've seen in PowerShell in a long time. And I like PowerShell already, so I'm kind of biased. I think it'll be pretty fun. I've been working on PowerShell for the past decade, and as I say, with me today is Jeffrey Snower, the originator of PowerShell.
Hey. And up here we have Eric Winter. Eric's trying to get his demo working. So everybody, good wishes headed his way, okay?
Particularly towards the network.
Yeah, it's the network, it's always the network. All right, so, hey, I wrote this thing called the Monad Manifesto. I hope you're leaving because it worked and not because you gave up. Okay, so I wrote this thing called the Monad Manifesto in 2002. And that was actually after having been working on these ideas for about a year or so. And in it, we laid out the vision for what we were going to do, what problems we were going to solve, and how we were going to go about addressing them. And if you go back and read that document, it's actually a pretty stunning document because it turns out that's exactly what we've gone and done. So in it, I talked about this idea of a monad automation model, replacing the traditional Unix compositional management one with a modern compositional management one based upon objects instead of text. And then, of course, that there was a monad shell, the ability for admins to get on a machine, to be able to interact with that machine, and then be able to script it and do things like that. And we delivered those in PowerShell version 1. I also talked about the requirement for remoting, that it wasn't about an admin sitting on a machine manipulating that machine, but rather it was about his ability to do that in order to create automation, in order to be able to then take that automation and run it on remote machines, large numbers of remote machines. And by doing so, to be able to amplify his power and control over the system and get paid a lot of money by doing so. And a number of people, a number of you have come up to me afterwards and said, hey, thank you so much for PowerShell. I've been so much more productive. I've got this promotion or this raise, etc. So kind of home run there. And we delivered this PowerShell remoting in version 2. Well, Monad became PowerShell. I also talked about how there was this Monad Management Console, about how all of our administrative GUIs should be layered on top of automation, so that everything you do through the GUI, you can also do through the command line. And we delivered that largely in PowerShell version 3 with the new Windows Server 2012 Server Manager. Everything in that you can also do via PowerShell. Now this is something that you'll see will take a while to have full completion, but we made a great progress on that in version 3, and you'll see more and more about that. But there was a fifth part of it, and that's where we come to today. I talked about the need for these idea of monad management models, the idea that said, yes, you have all this instrumentation and you can do anything you want to with it. However, what you really want to do is you want to get to this point where you have management models, where you take a particular area of management and you define the model and then you implement it through basically model-based management. And of course, everything else had to be done first before you could get to that stage. And I'm super pleased that now, what is this now, 11 years after having published the document, we're now at a stage where we can start beginning addressing these monad management models, and we're doing so here in PowerShell version 4 with desired state configuration. So, what in the heck is this desired state configuration? And the answer is, y'all seen this guy? This is Jean-Luc Picard. This guy rocks, and this guy was awesome, right? He figures back, sits there, he drinks his Earl Grey tea, and says, make it so, right? Wonderful world. Then there was this guy, Lieutenant Riker. He's the guy that went and made it so, right? And so this is what desired state configuration is really all about. The ability for you to sit there and say, this is the way the world ought to be, and then have the system say, yes, sir, I'll make it so. And then just like with Riker went and made it so and didn't bother the Picard with all the details unless something was not achievable, in which case he told him about it and let him decide what to do. And so that's the world of desired state configuration management.
That's it. It just occurred to me, actually, even before here. While I was here, I just thought, the other day I was worried about getting lost. I came and I had to learn the metro system and everything else. And I thought, wouldn't it be great if I just had my personal chauffeur follow me around the world and he knew everything, right? I could say, find me Italian dinner tonight, and I would just go. I thought that's kind of like desired state configuration too, because now it's no longer, I don't worry about getting lost. I don't have to learn the subway system or the metro system or even how to speak a language. I can just say what I want and somebody else takes care of it. Anyway, choose your analogy. It's a good world, however you like it. All right, before we talk about it in detail, though, we want to pop up a little bit and talk about some of the drivers that actually push us into this world. The first one, it's all about scale. How many of you have a mobile device, a phone with you? Thank you very much. Or some other, you could have like a Surface, right? And do you ever access the internet with that? Absolutely. The number of mobile devices throughout the world continue to explode, and most of us now have much more than one. Now, for every single mobile device out there, somewhere in the universe, there is a server that back-ends the data. The server actually goes and hosts all your data and provides your applications in most cases. And those servers have to be managed. And so what we're seeing is an explosion of servers, be they virtual servers or physical servers. And as the scale grows, we can't deal with them like we used to. We used to deal with them in a fairly complex way. You can't deal with complexity. Jeffrey tells me, I forgot where he got it from, but scale times complexity exceeds our current skill set. It certainly exceeds mine. And so what people do is they simplify, simplify, simplify. And so with desired state configuration, the first thing we're going to end up delivering is a strong simplification of how you say what you want. You're not going to have to describe as much. The second thing that's happening is the world is changing more quickly. Some people release every 3 years, 1 year, 1 month. Other people release multiple times a day. And what's the number one cause of breakage in any system? It's change, isn't it?
Yes.
So with that constant change, thank you. So with that constant change going on, things break, right? Not this week. They're not going to break. Nothing broke this week. Exactly. So, so what it really means that life in the cloud from a management perspective is you have rapid change at high scale, which leads to constant failure.
But it's worth pointing out here that, so indeed, change is often the root cause of failure. There are two approaches to this. One is, don't change anything.
Yeah.
We reject that thinking. That's just a bad way to go. Because in reality, why are you making these changes? And the answer is you're typically making these changes because there's a need to make those changes. So what we have to do
So if you don't make the change, you go out of business.
Exactly. So what we have to do is we have to make change safe. And that's what we're doing.
In fact, Netflix had that wonderful Chaos Monkey, right?
Chaos Monkey.
I love that thing. It goes around and makes random changes just to make sure their system can deal with it.
Yep.
So that everything is safe, so they're able to handle it. We'll talk a little about that, avoiding configuration drift. Okay, so what you want to be able to do is have your system continuously up and available. We want to have this rapid release cycle. And, by the way, part of this continuous change means I need to be able to deploy my applications on a regular basis. And so what that really means, I was just talking to someone again from a live site who was having some difficulties with this because they were developing in one environment. They would test in an almost the same but a little different environment, and then they'd get into production and they had to decide, oh, do we change this? Do we change that? Are the system drives different? And so as you flow from development to test, into pre-production, into production, you want to be able to change as little as possible and only that which is required. And so this notion of continuous deployment also plays here into it. And of course, what you want is you want to be able to move from ideas, from business need, into actually value delivered to your customers as fast as possible. All right. So that is enough of slideware, and we'll actually show you a little bit of code here.
Let's show them the details, man. The details.
All right, there we are. So,
behold,
that's a detail. So what do we have here? This is PowerShell syntax. How many are aware of PowerShell syntax? Just give me a hand, please. If you, thank you. Otherwise, I was going to have to stop and go somewhere else. All right, so this little configuration word is interesting. It sits in the same place as a function. So essentially, we've now are defining a configuration function. We've named it Fourth Coffee, and we've said we want it to apply to Web Server 1 and Web Server 2. This is just a PowerShell array list. Now, before I go too far, I'm going to actually start this off because it takes a couple of minutes because it's going to do something kind of cool for us. So I'm going to start it off for a second. I think that'll work. There you are. I'm going to come back and start describing it, and then I'll show you what we were just going through. So it says, okay, I want it to apply to Web Server 1 and Web Server 2. I have two VMs, just so you sort of see my environment, Web Server 1 and Web Server 2. So that's who we're going to apply it to. And what do I want to apply to them? I want to say, well, I want to make sure that IIS, the Windows feature IIS, is present. I want to make sure that the Windows feature ASP.NET is present. And then I just call it. And I actually start the configuration. And the system goes off and makes it so.
Wait, can I highlight that? So
Please.
Highlight that. So here, this configuration, imagine you replace that word configuration with function. What happens? A function defines code, right? Defines a symbol, this, that then when you give that symbol, that code runs. So here, we define a configuration with a name. When we specify that name, we create the configuration associated with that name. Okay, so it's completely isomorphic.
Absolutely.
Which is a cool word for the same shape.
Exactly. It's important to have cool words in there. And so what you're seeing here is as it's running, it's actually putting out a lot of information. One of the challenges of these types of systems, they're a little opaque, right? They're a little hidden, a little dark, so you need a lot of information coming back so that you know exactly where you're at.
Yeah, we spent a lot of time on this verbose stuff, so it was easy for you to find out what was going on, all the great details, so you know exactly what the machine's doing.
So here, what you're seeing, if it holds still enough for me to point it out, is you're actually starting to test to see if the Windows feature ASP.NET is there. It finishes the test, it finds it's not there, and it does a start of the set on Windows Server of Web Server 2. Does that make sense? So it does a test, it says, okay, it's not there, I'm therefore going to go ahead and call the set. And so in theory, if this all worked, what we'll have is actually IIS installed on these two machines. And there you are.
Woo.
Woo. Exactly, we have IIS. I'm okay with that. It gets better.
Wait, so show me the config again. Right? So all you did was you specified the two machines, and you said you want a web server present. Make it so. And it's so.
That's not bad. Okay, we're going to take it up one notch and say, all right, but we want to put something on that web server. Let's put a website. Now, before I get down here, a couple of things are interesting. One of the things we do here is we integrate PowerShell with desired state configuration, right? And so all you see here is a list of nodes has gone from a list to a variable, standard PowerShell variable. It could be any PowerShell expression. You could go access a CSV file, whatever you want, an XML file, a set of array of machines, wherever you stored it. You could go to a data store, I don't care where it is, pull it out and apply it there. You can access it. These could all be variables. There's nothing in here that you can't use a basic PowerShell syntax on the right-hand side, on the evaluation side, right? We keep it simple by saying, hey, the property you're going to store it to, you have a known list of those, but on the right side you can do whatever you want to get the data you really need in the real world. And that's where some of these systems have a tendency to fall down a little bit. They get a little too pure and they say, hey, we're only going to provide a declarative approach. And every time they do that, they find out, oh, I need some way to access real data. I have to think about it, I have to put an if statement in, and then they fall over here because you've integrated it with PowerShell. You have the mixture of what we'd call imperative, or how to do something, with declarative, which is what I want done.
Yeah, you will often come across people who will tell you, this is a purely declarative model. I will tell you for a fact, if it's a purely declarative problem, they're either solving a problem which is not particularly interesting, or they're lying to you, that it either doesn't address the interesting problems or that there's some imperative code. I remember, in fact, there was some guys who were selling this pure declarative programming model to Bill Gates, and Bill loved this stuff, and he beat me up mercilessly. You got to adopt this stuff. You got to adopt this stuff. It's like, what are you talking about? How could that possibly make any sense? This XML approach to purely declarative programming. I'm talking about program anything in XML. It's like, what the heck? And so finally, I reached out to these guys, like, okay, what are you guys talking about? And I looked at their XML, and I'm not making this up. I'm not making it up. Honest to God, there are XML tags for each. Starting value, end value. It's like,
but it was XML.
But what we've done here is we have this nice mixture. There's very strong power behind a declarative approach and imperative approach. And so what we've done is we've merged those two worlds to give you the best of both.
The second thing that you'll notice here is not just this mixture, to follow on with that a little bit, because it's basic PowerShell syntax, this is just a PowerShell parameter block, right? We said it was a configuration function, and there you have it. You can see, look, we just defined the parameters. Some are mandatory, some are not. They take defaults if you want to. So it's up to you. Now, the other thing worth interesting noting here is this word right here, this requires. And what that says is that, hey, this website requires IIS to already be installed. We're not going to run this until we already made sure IIS is taken care of. And if you continue on down, you'll see multiple of this, right? So what are we doing? We're making sure IIS is present. We're making sure ASP is present. We're stopping the default website. We're making sure that the file content that we want for the web content is present and available, and then we make sure the bakery website is actually in the right state. And that's it. That's all we're doing, right? We're pulling the website name out of the parameter block, as we said before. And again, this is simply saying, hey, before we turn the website on, we want to make sure there's content there. That's right.
Seems like a good idea.
That seemed like a good requires, and so there's this dependency. And what the system does is it creates a dependency graph. It just creates a tree of dependencies and says, hey, I'm not going to try to do this to make sure that resource looks like that until this one has been done. And it's going to wait until this one is done. But these two can run in parallel. They don't care. They don't have the same dependency. And so the parallelism is implicit, meaning it's expressed by the requires. Now, we don't do a lot of parallel in the engine today, but it's just all there and available. As soon as you want, you don't change your code, we'll just light it up for you later on. It's just the complete dependency tree.
If you have multiple requirements. Can you express multiple requirements?
I do believe so. I think that's a list.
Yes, exactly. It's just a list.
An array of strings that are the requirements, and so it knows who you actually require, and it waits till they're all met.
I think it's a string with an array syntax.
Yeah.
One of those two. Try it. Find out. Hey, you want to hear a story? So that requires may change. So don't get too upset if it changed. So we had this meeting with Rasinovich and the Azure guys, and they they want to go all in on this, totally, go, 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 go. Except you got to change that name. It's like, really? That's the deal? You change that name and you're totally in? Yeah. So it might become depends upon. So
depends
anyway.
On?
Depends on? Depends upon?
On.
On. Okay.
Or not.
Mark's very persnickety.
Anyway,
but the good news is everybody's converging on this.
We don't care.
This is
it
very
works.
cool.
All right, so we're actually going to run this now. We've chatted about it for so long.
Yeah.
And so in theory, what's going to happen is it's not going to try to reinstall.
But we notice the verb. The verb here is assert. So you just say, it's like, make it so. I assert this is true.
Right.
You will make it true because I've asserted it.
We sort of debated actually what to call it for a while there. And we finally said, okay, let's go. So what you'll see
Luckily,
is it's
we didn't
actually...
get Rasinovich in on that conversation.
Yeah, we didn't ask his opinion. We already started. And so again, it's starting the test. Now this is kind of an important thing. What you'll see is before it invokes a set, before it invokes any set operation, it actually invokes a test to see if the set is needed. And if the test returns false, then it goes ahead and says, okay, let's invoke the set. Let's make it so. Because the fault said, okay, it wasn't in that actual operation. So I'll show you here somewhere. There's a skip set, for example, right here. Web server 1, it starts the test, says, hey, is ASP.NET installed? The answer is yes. So it says, well, let's go ahead and skip that set. There's no reason to do that.
By the way, anybody developers in the room? Yeah? Okay, so if you think about it, this is just like a makefile for systems. Hey, test, is this up to date? No. Okay, then build it. If it's up to date, leave it alone. Only if it's not up to date do you build it.
All right, so let's get back here for a second. Now, this is actually... it's taking a little longer. I don't think we quite have our... oh, no. I have to work the demo gods.
Notice those great progress bars.
They are. Let it call.
Yes, sir. Is there a definitive way to see what the result of the test was? There is, but I don't know what it is. Yeah, in general, what we're going to show you in this path, we noticed this afterwards, is like, hey, each one of the resources has a test, a set, and a get. Okay, and so what we're showing you in this demo is all the set portion path, but in fact there is the test to say, hey, I assert the world is this way, tell me if it's true or not. And then there's also a get path where you can say, hey, go get me the state of the world. So, but we didn't include it in this talk because this talk's got quite a bit to it. Yeah. By the way, so I don't know where you are with this, but as I was setting up the demos for this stuff or using some of the demos, I was trying, let's try this, let's try this. I was breaking it right, left, and center. And I got to tell you, it was so wonderful because whenever I did that, I'd just go back and I'd say, assert, the setup, and it would go and clean it all up and make it so wonderful. And what happens when you have, it's really a transformational thing. I mean, look, I knew this story like a year ago because we invented it, right? And so I knew it, but when I actually used it, it's just such a delightful experience. It's transformative. And so once you use it, you'll get it. You'll say, oh my gosh, how could I have ever done it without it?
Now in theory, then, if we did this all correct, we actually get something besides IIS. The system has decided to run abominably slow all of a sudden. Well, that's good.
So what's up? Are you running? And
that's fine. We should keep going on a little bit.
Okay.
And so, by the way, one thing worth noting here, actually, is when we invoked it here, we invoked it with all the set of parameters we talked about before. Now, this start is actually creating a job. In this case, we've gone ahead and we've said wait. We've had the verbose output, so it actually is coming back. That's what you're getting the streams on. And what you're seeing is if we didn't say wait, in fact, it would just go as a normal PowerShell job. You can manipulate it. You can stop it. You'd have a couple of them underneath there, one for the web server, so you can control them like you would any other PowerShell environment.
Oh,
and, whew, thank heavens, it did work after all. Okay, there you are.
Cupcakes.
We have cupcakes. I'm not quite sure why we had to. These cupcakes are worth the effort, though. Except the only problem is you can't order them because you click on it, it won't work. They're symbolic cupcakes.
Those are expensive
all right,
cupcakes,
so that's the basic
friend.
notion of what PowerShell desired state configuration is. We've covered a lot of material in there. We'll try to hit a few more things as well.
Great. So let's talk about what this thing really is, okay? So some people say, well, hey, the desired state configuration, is that a PowerShell thing, etc.? Let me be really precise. I'll say it, and you'll hear it. You just register it. It'll take you a while to understand what it really means. Desired state configuration is a standards-based management mechanism first implemented on Windows using PowerShell as an authoring language and a provider model. Okay, so it'll take a while to figure that out, but and maybe even a couple releases and a couple discussions with partners over time. But it's a standards-based management tool first implemented on Windows using PowerShell as a scripting language and authoring engine. So the whole point here is that it enables you to define all things, have the correct configuration. So all the things in your data center, remember, we're all about the cloud now. And the cloud is not just about a server, it's about a lot of servers, it's about all the networking and storage devices, etc. So you need to have a system which can configure them all. It's a standards-based management first implemented on server. Okay, now you get where I'm going? And now the next thing is it enables this model of continuous deployment and configuration drift, right? As soon as this guy joked, he said, everything's going to be fine because all the people who are screwing it up are here in the talks. They're not back home screwing up the systems. And that's exactly right. Once you get a system in place, it tends to have entropy. Things change. And this system allows you to say, here's the way I want it to be, and I want you to keep it that way and keep keeping it that way. And as I mentioned, we use the language. And so what we're doing here is it's all based upon this CS term, idempotency, which basically says there are certain types of operations that I can perform over and over and over again and get the same result. So for instance, 2 plus 2 is, adding 2 to something is not idempotent. If I do it 5 times, I get 10. If I do it 20 times, I get 40. But if I say set it to 2, I can set it to 2 over and over and over and over and over and over and over again. And whether I do it once, 10 times, 100 times, the result is the same. And so you could have always done this with scripts. But what we're doing is we're saying, hey, write scripts in an idempotent way, and then we'll build a tool chain around that to give you these properties of desired state configuration. So that's really what's going on.
So we're going to show you. We'll show you one more thing here in terms of how we actually deal with configuration drift. So it so happens that I'm going to go ahead and enter PS session on web server 1. Stuff happens. I say, particularly once you have things at scale, things automatically start to break a little bit. Such as soon as I have 2 VMs running on this and have practiced it 95 times, it starts to go abominably slow. So we're going to, in theory, get a little bit of remote in here running again. And the point is, when you actually break something over time, what you do is you simply rerun. Oh, dear me. I don't want a network. It's all local. Right here on the VM, should be able to keep running on them.
Well, you can just RDP into it.
It'll go just as slow, I think.
Could be, maybe not. Yeah, where's Rasinovich when
we should actually run this again, exactly.
Quick, get Rasinovich on your speed dial. Get him down here. Yeah, just try it.
We'll see which one gets faster.
It's a race.
Well,
the which sequence? Oh, task sequence. Yeah, we'll talk about in particular how it relates to various existing products. But basically the design center for this is the cloud and DevOps scenarios. Okay, so very concretely, I missioned the team and I said, listen, you need to be able to design, deploy, design, develop, deploy, and debug this with a junior engineer. If it requires a senior engineer for any particular step, you've messed up. Now, in general, that is not the enterprise scenario. In general, the enterprise scenario is about lots of edge conditions, right? Edge conditions, supporting politics. This guy likes it this way, that guy likes it that way. How am I going to merge those different visions? On Tuesdays, we do things differently. The cloud isn't that way at all. In the cloud, there is no politics. There is one way to do things. There's uniformity. The way you drive scale is to eliminate complexity. And so that's what the Cloud Design Center is. And so what we've built here is a very, very, very simple engine. When you take a look at the verbose, you're going to be able to see. You run it the first few times and you're like, what the heck's that? That looks complex. Spend some time with it, look at it, and then think it through. And you realize that, oh, you'll be able to see the entire design of the engine through the verbose log. And you'll see that it's a very, very, very simple engine. Now, there's a pro and a con to that. You'll know exactly how this thing works, and so you'll be able to get exactly what you want out of it. But if it doesn't meet what you want, that's the way it works. There aren't a lot of edge cases with this technology. We've gone out of our way to avoid that. Yeah?
All right, so RDP looks like it won.
All right.
So we'll get back to what we might end up doing, actually just shifting out. I'll grab another laptop, or I'll just rebuild the whole system on the fly. I'll get to see what we do.
That'd be fun.
Desired state configuration.
Yeah.
Anyway, in this case, I'm going to go ahead and stop the website on web server 2, and we'll actually prove it stopped here with our get website here. There it is, it stopped. And so we come down here, and we're still not through with web server 1. We will just give up on that one. There we are. And you come down here to, in fact, web server 1 or web server 2. We'll do a refresh, and one of these will have actually stopped.
So this is the example where you're now here at TechEd doing your job, and one of the junior admins back home went and screwed things up. So your boss calls up and says, "What the heck are you doing at that conference when everything's going to heck back here?"
Exactly. And so what we're going to be doing is we're going to actually come back here. We're going to run the same thing we ran before. Assert website 2, which is the same code we should before. And in theory, oops, let's make sure it's actually stopped. We showed it stopped. There it is. You see, it can't be displayed, so we know the thing is not working. In theory, if we rerun it, it should just reset it to the same basic state.
And by the way, using PowerShell Web Services, you can do this from your phone. You know, have you seen that PowerShell Web Outlook? So, what is it? PowerShell Web Outlook? Is that what we call it?
Web access.
Web access. Web access. So you can. This is awesome. You can go from your phone or your tablet, and you can set up IIS so that you connect into it, log in through a browser, and connect to any machine in your network, and you can start doing PowerShell from there. So you're here. Your boss calls you up and says, "What are you doing at that conference? Things are going to hell." You get on your phone, dial in, say assert the state, and
in theory, there you are. Whew. Okay, they came back again.
Selling cupcakes.
Back to selling them again.
Hardening the arteries of Europe.
Conference. Oh, you are. So that's the Notion configuration drift. We do a similar one where you can just remove all the files. It doesn't matter because the system goes through and makes it so again. Just resets, resets, resets. You know, and the key thing is you can set this on like a schedule, right? In fact, it was I was talking to somebody. They were saying, well, how would I diagnose if I have 10,000 servers and I want to figure out which one was failing? And I said, well, you got two choices. We are putting all this information into the log, and you could do a get target resource and get a bunch of information. Or somebody else who was listening said, or you could just rerun it again.
Yeah.
Just put it on a schedule, right? He says, and then you just never know. He says, now you do want to know over time if things are continually failing, you have a problem, a systemic problem. But normally these environments, you don't want to know about every little failure. Just run it on a schedule, and the website reappears, and you're all done.
Yeah.
You're copacetic again.
So your analogy earlier was actually a good one. You talked about how I'm going to change it so it works. But
good.
This idea of not needing to have somebody follow you around and you just say where you want to go. Well, we have that. It's called a GPS, and this actually works like a GPS, right? You say where you want to go, and then if it turns out like, oops, I missed my turn, what happens? It recalculates and says, oh, well, you got to go here, or you took a wrong way, a wrong turn, and it dynamically recalculates and gets there. Same model, right? You've said what you want to have happen. The system's off there figuring out how to make it so. So in this case, originally you said, hey, I want the following thing to be the case. None of that existed, so it put it all in place. Next, somebody went around and whacked something, turned something off, deleted some images. So it says, oh, well, here's the way it's supposed to be. So I got to go start that thing. I got to go replace those images. Oh, I love this guy. What happens if a reboot's required? We're very smart about reboots. So first off, imagine the case that says, I'm going to do something, and a few reboots are going to be required.
By the way, we're going to go rebuild this whole thing just for fun on the fly, so I'll let you get back to the slides and you can have one.
Or you can do it, but use his machine. Anyway,
So you
so
wanna bring it
the
up?
thing about the reboots is when one of the systems says that it needs a reboot, it signals it to the engine. It doesn't do the reboot, because if it did a reboot, then you start over, continue on. The next guy might require a reboot. So what happens is you do a full pass, keeping track of this. This is like reboot consolidation. Okay? Now, they all do as much as they can. You see that a reboot's required. You get to decide, hey, do I want to do a reboot when a reboot's required, or do I want to be notified and I do the reboot? In either way, once you do the reboot, we do it again. And we go and we continue to evolve it. That's the point of idempotency, is I can run this thing as many times as I want, and it's safe. So I just keep running it until a reboot's not required, and then we've converged. And then you'll see we've got a schedule that says, oh, how often do you want to do it? I think by default it's every 30 minutes. We'll go and we'll reevaluate the state of the system. Okay. So that's the answer for reboots. So again, back to the separation of intent versus make it so. So if you take a look, anybody following the DevOps community, some really innovative stuff going on there, and they were the ones that had this concept of, complexity times scale exceeds our ability to cope with the situation. Therefore, what you want to do, because cloud's all about success, which means scale, right? I'm going to serve everybody in the world. You want to simplify, simplify, simplify. Anyway, one of the techniques that they have, by the way, the whole DevOps community got started when some guy stood up and said, we were all trying to figure out how to release software like twice a year or 3 times a year. John Allspar stood up and said, at Flickr, we're deploying software 10 times a day. People said, what'd you say? 10 times a day? What do you mean by deploy? And he really meant deploy. And this was the example of using tools, changes in tools and culture to make change safe. Okay? Now, in the DevOps community, they have this notion of continuous deployment, right? That deploying software, deploying new software, is not something that you think about. Like right now, that's how we all do it, right? Oh, there's new software coming out. We got a plan, got to figure out how we're going to do it, how we're going to get from this state to that state, etc. He said, no, no, no. We have continuous deployment. It's not an event. It's just like breathing. We do it continuously. That's what we do. We continually deploy things. Now, in that environment, there are these stages, right? There's the developer. He needs to deploy things. And then when he's done and he's satisfied that things are working, he wants to hand it to the test organization, where they're going to run it in a pre-production environment or in a production environment in what they call an A/B test, which says, hey, if I've got 100 servers, I'll run it on 5 of them and see if the world blows up. If it doesn't, then I'll try it on 10, and etc. And then finally in production. Now, the point of that is that you want as little to change as possible. So there's this notion of the environmental configuration. Hey, here are the specific machines, here's the specific IP addresses, etc. And then there's this structural information. I have to have the web server, it has to be present, here's this thing. I've got a front end. I got a front end, I got a back end, and I got a front end, middle, back end. Now, in a developer machine, your environment information might say these 3 things all exist on one node, or 3 separate nodes as VMs. In the test environment, you say, hey, that structural information is all exactly the same, but now I'm going to have 3 front ends, 1 mid-tier, and 2 back ends. And then when you're happy, you go and you say, in production, I've got thousands of front ends, hundreds of mid and dozens of back ends. But everything else you want to be the same, right? That environment, that structural configuration. And so what you want to do is you want to have as little churn as possible. And that's what this is all about. And then that's from the make it so perspective, from the intent perspective. From the make it so perspective was the stuff I was mentioning before, this idempotent implementation. Basically the ability to say, find out where things are and then converge on the desired state. So let's describe the model. This is where it gets fun. So this is the architecture.
Actually, go back up for a second.
I'll go back up for a second.
Well, we'll think. We'll theorize.
But I don't know if you know what's going on. This guy is scrambling. You know, like that duck who's like on the top and underneath the water paddling like hell? That's him. He's rebuilding the entire demo system. But remember I mentioned that I did that? And you just sit there and you say assert, configuration. It takes a while, but it ultimately just gets you back to where you were.
Yeah, actually, in fact, I'll show you. We have two different laptops up here now. Both are sort of in a different state. What we've done is we've gone ahead and reconstructed the...
Should I show them?
Yeah, show them this one. This is fine. This is actually another one. We gone ahead and said, okay, let's pull up Fourth Coffee. Let's go ahead and create a couple of VMs. We've done that. I'll say the other thing really cool about this, and if I, in theory, refresh this, we will see cupcakes if everything worked. There you are. All right, we've got a system back and running. What's fascinating about this is that it turns out to transfer pretty well also. That is to say, I can take a configuration on this machine and send it to that machine much quicker. We actually had a lab we ran at the PowerShell Summit this year where we took a very similar approach, even using PowerShell v3. And within a very short while, 20 or 30 minutes, we actually had almost 100 people actually able to do this type of create the VMs and deploy cupcakes to their actual systems. So the other thing really nice about this approach is how it actually scales out to people. So what I did want to do here is to run ISC as administrator, is to actually show you an example of actual environmental configuration, if we could.
Oh, great.
So let me see if I'm down here. Go to website, and this is a pretty simple one. Configure environment 1. And this is simply says, hey, we're going to specify all nodes, and this is all nodes we're going to attack. We don't care how many there are. There could be 100, could be 1, whatever it is. This one says for all nodes, the website you're going to have is Fourth Coffee. The source path for the original source of the actual content is going to be bakery website. Your destination path is here, and the default website. And then, on a per-node basis, you can have additional information. In this case, it's pretty simple. We give it a name, and importantly, we tell it what role it is. This could be any number of roles. It's actually your choice what string you want to do with it. What makes it particularly interesting, then, is when you pull up
watch this.
This configuration environment. Remember, we had a simpler one before. Should I show them the simple one just to remind them where we are?
Yeah.
There, we'll show them. This is where we were before, right? We just had a node name here, and then we had the basic requires. But this takes a bunch of parameters. In this case, we say, no, we're putting all that information into the environmental configuration so that they don't have to touch it. And this is all your structural information.
So just to be clear, that all nodes, go back to my example. In that configuration file, the environmental file, you've got like your front-end nodes, your web nodes, your mid-tier, and your SQL nodes. So then the question is, well, here's the configuration I want to apply. Which ones do I apply it to? And so that's what he's doing there. All nodes where the role equals web, and you grab the node name. By the way, that's new PowerShell syntax. It's crazy cool. By the way, am I going to embarrass myself if I show people that? Does it work?
You will hear, no, not on this machine. It's not going to. So.
Anyway, that's now general PowerShell syntax. You can do that on any collection.
Absolutely love it. So, and what's key here now is you've gone ahead and you've accessed those where the role equals web, as Jeffrey said. And on all of those, we're going to do this. And then you have various information, right? It pulls out for my node, what's the default website. Now, it turns out they're the same in this case for each node, but that's not always so. So anytime you have specific node information, you can put it there inside of that sheet. And we just do a little hot rod on the syntax. We know, okay, I'm node right now. It's kind of like this or something. You know, it's me.
It's a clever way to, it's an alternate way to do parameterization that's specifically useful for desired state configuration.
Right, and so if we were to run that same thing, you'd get environment 2.ps1, PSD1. Now it's where I want tab completion.
If you control C, you get it.
Oh, that's it. No, that's the wrong one. Tab. I need tab completion on prompting, don't I?
Yeah.
In theory, this goes back again, and what you'll see, now that's a little faster, don't you think?
That's the way it usually works.
That's the way it's supposed to be working. In 6 seconds, you come back, you revalidate, hey, in fact, our cupcakes have not disappeared anywhere. Now let me show you one more thing. This is a little more complicated because I say we can take it to the next level.
Actually, do you want to do that? You got to make sure you got time for his demos. We're running out.
Pull this.
Take a look. Just decide.
I'm going to show him, and then we'll let him do the demo, and we'll come back. How's that for a deal?
Okay.
This is going to go. So what we do here is actually we can go inside one of these similar configuration files. This is a little more complicated than what we showed you before. In this case, I've actually said, hey, the system drive, which might change, the demo folder, whatever it is you want to do. In this case, we can simply say, instead of 2 servers, we want 3. I could say 100, but that will take a little longer because you're going to have to create all those VMs. And I might eventually run out of memory on this little box. So we're just going to say, hey, we want to go ahead and have 3 of those servers. And so instead of having 2, maybe we'll get 3. I'll go up here to my more complicated site. And I'll say assert website. And it'll actually start processing. And because we've already gotten everything installed on VM1 and VM2, it'll sort of skip all those. But in fact, it'll automatically create a VM for us, deploy the website. The only thing I changed was this. And this is the important thing, because this is the file then, if I might a little bit, so watch back and forth for a second. Where the hell? Where I want 4. There you are. There you are. That file I just showed you, I changed to 3, is right there. $global web server count went from 2 to 3. That's the only thing that guy's got to change. You don't want him touching your other stuff. You don't want him saying, you don't want him to mess with the fact I need IIS. That's structural. That never changes.
That was worth showing. And so
all
do you
right,
have
so
the,
we should, however, get to the next slide.
Okay, anyway, he would have shown that it does it. Now I got to tee this up with the details. Okay, so here is the structure. There's a push and a pull model. This is the push model. Okay, we got a 3-part architecture. On the left side, you have authoring. On the middle, you have this declarative model. And on the right, you have the make it so phase. So let's talk about the middle. What really happens is that each node gets this configuration staging data. It's got this standardized declarative. There's a single declarative document about the way the world ought to be. This is standards-based. Okay, which is to say a MOF, which is a WMI set of instances. That MOF then gets sent to the node, and then the node makes it so. It has this thing called a local configuration store. That tells you, hey, what is the way the world is? What did it used to be? And what is the pending state? So that's the configuration store. Then you have a parser to go parse that document and then figure out how to go make it so. And then you have these imperative providers. These are the things that actually make it so. Now these can be WMI providers, or they can be PowerShell scripts. Okay, and these providers are then monotonic, which basically means relentless. Just do it, however it takes it, do it. Imperative, that's say versus declarative, and this idempotent, which is to say they're lightweight and you can do them over and over and over again with no bad effects on the system. So then, excuse me, the question is, well, okay, great. So now I take the standards-based document and I send it to a node and it makes it so and tells me when it doesn't. How did I get that document? And here's the critical answer. Any way you want. Any way you want. This is a platform play. And so what we're showing here is PowerShell version 1. You can create the document with PowerShell version 1, 2, or 3. Those things are great for creating documents. You do not need anything special. You can just create the document any way you want. You can use Notepad if you want to create that document. Not the best tool, but it will work completely with this architecture. Now, PowerShell version 4, however, we have tweaked PowerShell version 4 to make it particularly easy to generate these documents. And that's what Kenneth has been showing you. But it is not required at all. And in particular, there are third-party languages and tools, because this is a platform play. And anybody can use our engine any way they want. And with that, I'd like to introduce you to Eric.
Hi, my name is Eric Winner. And I work on the Virtual Machine Manager component of System Center. And for the last year or so, we've been working in conjunction with the Azure team to define the new infrastructure as a service virtual machine role. And there's a few key concepts we've been focused on. One, the new virtual machine role, it's a model for creating a virtual machine and the applications inside the virtual machine. 2, you can create multiple instances within the role. So you can have 2, 3, 4, 5. As Kenneth was showing in some of his scripts, we have a similar notion in the virtual machine role. The other agreement we have is we're initially delivering this as part of the Windows Azure pack that is being released in conjunction with all the 2012 R2 wave. And then in a later release, the Windows Azure team is going to support the very same model directly in Windows Azure. And there's a model, there's an API, syntax, that will all be consistent between the on-premise clouds, clouds running at a service provider that are running Windows Server 2012 R2, and then also in Windows Azure. And then part of our design point around configuration of the virtual machine was to be pluggable for configuration systems like Puppet, Chef, and PowerShell DSC. So I'm going to show you today a model that I built. So I'm going to be a service provider. I'm offering a gallery item that will take anyone's PowerShell DSC definition. And you've seen us running here sort of on a local server. I'm running locally. I'm going to use those very same definitions you've seen Ken and Jeff using. And I'm going to now push it to a service provider in a scalable VM role. So as I scale my website in and out, since the model remembers my PowerShell DSC, any instance I create will be configured identically. So I just go down here. This is the new Windows Azure Pack portal. I go down to New, Virtual Machine Role, and I can create from Gallery. Here you see I can model many finished workloads. Here I've got a PowerShell DSC item. I give it a name. I'm now going to join it to my domain. And then here you see a computer name pattern, this pound, pound, pound. We auto-generate the computer name as we generate new instances. Then here's the application settings. So you can see I've had these pre-filled for the demo environment, but these are the exact same files that Ken's been using. I'm going to assert the website, the Cupcake website. I'm going to pass a configuration environment that we were just looking at. And then in this one, I've said I will pull the PowerShell files from a website, and then I'm going to grab the content also from a hosted location. This could be Azure TFS. This could be a machine you're running on your own CorpNet. And that's really it. I've now configured. It should now be configuring, provisioning right here. It pops up provisioning. And so now the VMs will be built. It'll pull all the PowerShell DSC that it needs to and locally make those machines run using DSC to configure all the applications running inside them.
Great. Thanks, Eric.
Yep.
You want to show the other video, right?
Yeah.
You want to speak to it?
All right. So I mentioned that this is a platform play. And of course you're going to see the System Center guys get up here, right? We've seen throughout the show, there's just been great integration between Windows Server and System Center and Azure. But what we're now going to show you is a videotape of OpsCode, Chef's product. They've got a product called Chef. And what they've done is they've integrated Chef on top of desired state configuration. Which machine?
I am one.
One. And you got audio?
We got audio.
And we have audio?
Hello. I'm Adam Edwards from OpsCode, and I'm really happy to be here today to talk about how DSC and Chef enhance Windows as a DevOps platform. If you're not yet familiar with Chef, it's an open source and highly scalable automation system driven by an open source community and OpsCode itself, and it's used by large organizations like Facebook down to the smallest of startups. Today I'm going to show you how we've integrated DSC with Chef to allow Windows administrators to take advantage of DSC capabilities within Chef DevOps workflow and practices. So we're going to show how you can use DSC and Chef together to set up a website. Right now I'm showing you two Chef recipes. And in Chef, recipes are configuration expressed as code in a Ruby-based domain-specific language, or DSL. In each recipe, we've embedded what you may recognize as DSC PowerShell script. And this embedded script is going to help us set up the website. On the one on the right, we have a recipe that will set up the IIS feature in Windows. And you'll probably recognize the embedded DSC code right here. We also, above the DSC code, we have some parameters specified in our DSL that let you control, say, which feature gets enabled with this embedded DSC code. So here, the goal of this recipe is to enable the IIS feature on Windows so that we can have a website. In this recipe over here, we have more embedded DSC code, and we have some other Chef stuff in here. There's a resource called cookbook file, which is a normal part of Chef, and that file is going to refer to the default website's main web page that's embedded in our Chef cookbook. And cookbooks are the unit of packaging for recipes in Chef. Beneath that, once again, we have this DSC configuration script resource, which is going to allow us to embed DSC configuration script in this Chef recipe. This one, you can see, will take that file and use the file resource in DSC to put it in the right location for the default website's main web page. So in order for these recipes, this code, to be useful to configure nodes, we need to upload it to a server, to a Chef server that stores the cookbooks that contain these recipes. And we'll show how we can use our administration UI in Chef to configure these nodes, to configure the nodes so that these recipes will execute on them and thus give us our website. And we're going to try that for the machine we're looking at here. So in order to build our website, we need to have both of these recipes, and we're going to run both of them. Let's just check this system, make sure it doesn't already have a website. So I'm just connecting to the port 80 on the local system, and yeah, there's nothing here. So now let's go switch over to the Chef server. This is hosted Chef, and we'll see how we can take the Chef server, which now contains, we've actually already uploaded the recipes that you were just looking at onto the Chef server. This means that nodes that are being managed by Chef can now download these recipes and run them on the nodes. In order to make that happen, we've got to set up the particular node we're running on, or any group of nodes, to have these recipes. So I'm going to go take the recipe, the IIS recipe that was on the right, put that in there, and I'm also going to put the website recipe on there. And I'm going to make sure they're in the right order too. Okay, we have to save this. And now the Chef server has the correct configuration. We can tell the node to go talk to the Chef server and enact the configuration on the system. So we'll run a Chef client, which is like an agent for Chef, and it talks to the Chef server, and it's going to download those recipes onto the system. And typically the Chef client is treated like an agent that runs in the background on your system. Here we're running it interactively just so we can watch what it's doing. But it's going to go get these recipes, and after it's gotten all the recipes that it needs, including the IIS recipes that we uploaded, it will then attempt to enact the configuration on the system. So it's going to start executing the DSC configuration script that was embedded in the recipes. And you'll see it's accessing the local configuration manager for DSC. It's, believe the first thing it has to do is configure the IIS feature. And so that's what it's going to do now. After that happens, then the actual default website file will get placed, and that was another, that was the other recipe. And now that IIS is configured, I think it's going to go do the website file, and it looks like it says it's all done. It succeeded. So let's go take a look and see if this website is available now. So let me switch to this other tab here. Let's try this again. All right, there we go. So with DSC, it was pretty easy to just go on ahead and configure a website, get it up and running. There are lots of other resources in DSC. All of those are things that we can take advantage now with Chef because we've done some integration, and because DSC resources behave in a nice idempotent way, just like Chef resources. The integration is really straightforward and reliable, and works well within the DevOps sort of DevOps best practices that we enforce with Chef. So this is really just a fraction of the kinds of things you can do with Chef and DSC together. And I think that as more Windows organizations adopt DevOps, DSC is going to be a huge enabler for them, and for all the vendors who provide DevOps tools like OpsCode. So on behalf of OpsCode and the Chef community, I'd like to thank the PowerShell team for making a contribution that will help the community do even more on Windows. And I'd like to thank all of you here as well for watching us. Thanks.
Okay. You're welcome. All right, so that's the push model. Again, highlight that we take these desired state configuration documents, which are standards-based documents, and we can take them from any provider. So what you've seen, we've been doing a lot of PowerShell version 4, which is a nice, simple authoring model. The tool vendors can write the documents themselves, or they can leverage PowerShell version 4 to create the documents. But it's very much of a platform play. And do you want to talk about?
Yeah, that's one more thing. The other part of this platform play is, of course, the providers. Right over. No, go back to it. Go back to your slide. Thank you. The imperative providers, that little dark blue piece, that's really important. Because you can say, make it so as much as you want, but if there's no one to do it, then it doesn't work so well. And so we've tried to make it really easy. We started out, because this is a version 1.
It's worth stressing. This is a version 1. Just like PowerShell version 1, we had the basic concepts and we had this awesome engine. We didn't have very many commandlets. Same thing here. Now, just like with PowerShell version 1, it was extensible so the community could write their own commandlets. And so with that...
Exactly. And so here, for example, what we've done is you've seen this thing called website, right? We're only shipping like 12 or 13 resources. Files, one of them. Windows features, certainly one of them. There's any number. We actually have a whole zip resource and an archive and a bunch of others. But we didn't have a website resource. Now, we should have one.
Website isn't one, yeah.
But we're not going to ship with it, it turns out. We'll have to blog it or something. So instead, we had to write one. So I'll just show you what it is. It's sitting here on the system. Under our resources, what do we have? We have Demo IIS website. And this is 15 KB worth of code. That's it. That's how we actually got the whole websites deployed. That's it. You've seen the front end. This is the back end. This is the complex part. And the complex part is made up of 3 functions in PowerShell. Yeah. Right? They are a get, because you want to know what state you're in. They're a test. You want to test, am I in the state I'm supposed to be in? And then they're a set, which is the finally make it so. And I'll just show you a little bit what that looks like if you take a look at the test. So in the test, the first thing to note is a set of parameters. Again, it's a basic PowerShell parameter function block. No surprise. What's kind of cool, though, is you notice this here, ensure, right? Well, that somehow, not surprisingly, matches this ensure. Right? So essentially what we're doing is we're taking the properties, we're going through the local configuration manager, and in the end, we call your PowerShell function with the value for that property that it's supposed to be passed to your parameter, right? And so we have ensure, we have name, all of these, and again, they're mandatory, so we'll use the usual PowerShell enforcement mechanisms come into play automatically, right? Validate started, and then inside if you're particularly on the test, then it's your job to make sure it's really so, and you are free, of course, to do usual PowerShell. This is the idempotent automation, but here you just run your command sets. You just run your command line that you already have. Now, while we only have 10 to 14 desired state configuration resources shipping, it turns out we have almost 3,000 PowerShell commandlets shipping on Windows, plus a bunch in the community. And all of them are accessible, of course, via PowerShell script. So you will end up, if you take advantage of the system in its first version, end up probably writing or sharing a set of providers, but they're not that hard to do. And here I am on Web Server 1. This is, by the way, back to the first system that was going slow, so we just rebuilt it all. So hopefully it will be a little more performant. No. Yeah, there it is. Okay. And we're going to go ahead and see if I get my typing all correct here. That's right. And we're going to go ahead and see what we got here is get module command dash module demo under IS website. So this is it, right? These are the functions, and I'm now actually on that target system. And the reason this is kind of interesting is when you're debugging it, occasionally it's kind of useful to reach out and touch someone, reach out and touch a system and say, hey, can I actually do a test of this test target resource, right? Dash, what was it, name equals fourth copy, is that right? Oh, did I get it wrong?
Tab.
Is that right? Thank you.
Tab.
Name, tab, thank you, exactly. Fourth coffee dash physical tab C. Should I tab here? There you are. And there it's all. It just returns true. That's its whole job. False. Hey, right? So that's all it's done is it's guaranteed that you can actually do that. And it's fun to just actually go out and test it. It turns out that was particularly useful.
So that was your question earlier. Yeah, you can.
Yeah, you can actually reach out and touch it. All right. So we should now shift back here. I'll actually go back here to this website, and while I speak to something, we're going to go get rid of all the VMs for this demo. We have a couple of VMs going. And the clear demo just gets rid of the VMs for me pretty easily, so that's what I'm running there. And hopefully we'll be able to show you the next thing as well.
So this was the push model.
And now, drum roll, pull model. I didn't used to have that red stuff highlighted, and we just made people try to figure out what was different. The only difference is that we changed the word push to pull, and there's a new arrow coming back to a pull server. And this gives you the ability to, in fact, send out to the different target nodes 2 pieces of information. When you create the VMs, you give them a unique identifier for themselves. Oops, who am I? And then you give them the URI of the pull server. And I'll show you this actually start.
And this pull server is a web server with an OData interface to it, a well-defined OData interface.
And we'll start it off, and then I'll show you a little more about what it looks like.
And there are lots of reasons why you want pull servers versus push servers. They're both interesting, but pull servers work better with NATs and things. in network address translations where you can't necessarily reach things. By the way, the other thing I should have mentioned is, as that thing's going through and evaluating the document, it says, oh, here's a thing that needs to be configured, looks for a WMI provider for it. If so, hands it to it. If not, says, oh, is there a PowerShell module that handles this resource? If so, hands it to it. If not, it looks back, if it's been configured, looks back on a server to say, hey, server, do you have a PowerShell module that can handle this resource? And if the answer is yes, it will download that PowerShell module, deploy it, and then use it. So in this way, we're in fact page faulting in PowerShell modules as we configure the system.
In fact, hopefully we're going to show that exact scenario to them.
Oh, sorry.
Because what we've done,
Stole
this
your
is
thunder.
perfectly described it. Because what we've done, in fact, is we've just gotten rid of all the VMs. As we set the VMs again, all they have is that URL going back. They don't have any resources except the ones we shipped the file. They don't have the website one, for example. And so they go back to the poll server and say, hey, I have a configuration. Do I have all the resources for it? And when it doesn't, it goes back and asks for them. So, and that's the only difference, right? In the push, you're pushing everything out. You assume stuff is there. In the poll, it goes and gets its own configuration. The poll server says, who am I supposed to be? And then it tries to make it so. I'm going to flip back here to code again in the few minutes left. And so what you see is we've now got a couple of web servers up and running. Now we've actually paused the demo in this case because if we are lucky, we're going to actually go into going to go back into Web Server 1, and we'll actually show you kind of where it's at, because it's halfway through the process. File, star pal, star mod. There's nothing there, right? There's nothing there. What it's going to do is it's actually going to come. Got the poll server right here. It's going to come to this poll server. It's going to go in this directory and say, hey, this is the configuration folder. It's going to go in and say, hey, I'm this GUID. I'm this guy. That's its unique ID. It's going to open it up. That's the checksum to see if it changed. That's important too. It's going to open and say, hey, do I have this resource? Now, this is Moth. This isn't direct PowerShell. You normally don't have to go this. But here it's going to say, do I have the IIS module? And the answer is no, because we just showed that. And so it's going to ask for it. How's it going to get that? Right here. The poll server is now going to say, oh, I have this zip file right here. Let me give that to you. The local configuration manager on the target node now says, oh, thank you very much. I have that module. It will unzip it and then invoke it, in theory. That's what it's supposed to do. And so if I come back here, I actually have this. This is my, okay, continue on. It'll continue on, actually download the module, unzip it, and run it as we described. And so we'll come back to that in a few moments. I want to make sure people had that kind of in focus. Now, at least I don't think it's there yet. It takes a little while to actually get it. See, we can sit here for the next. There, oh, there it was. A little quicker than what I thought. Oh. So it automatically downloaded. You see that little shift between the two. It downloaded. Now it's actually going to start installing IIS and then installing the website. And in theory, over time, we'll actually get our cupcakes back, but they're going to take a little while because it's installing IIS at the moment as we speak. Why don't we continue on with the rest of it?
Okay.
And we'll, because we're got a few moments left.
Okay. So how does this relate to System Center? Well, as or to the various things I mentioned to you. System Center Configuration Manager really is kind of our enterprise desktop-oriented system. desired state configuration is very much focused in on DevOps and cloud scenarios. And again, I draw the analogy back to PowerShell version 1. PowerShell version 1 was a distinct thing and had sort of minimal system center integration at the beginning, and then it grew over time. And if you recall, one of the first and best adopters of PowerShell was the System Center Virtual Machine Manager product. And so too, here again, once again, the System Center Virtual Machine Manager is first and best adopter of the desired state configuration management that you saw from Eric. And of course, PowerShell, as I mentioned, it's really just the language components that drive DSC. Okay.
So related sessions, just so you know, actually I do want to hype at least the ILL. We have somebody actually going through the whole DevOps lifecycle who shows some desired state configuration. I think that's Larry doing that. And then tomorrow morning, you actually put your hands on the bits and actually play with them, and you'll be able to actually try it out for yourself, deploy as many cupcakes as what you would like, because of course, we do like cupcakes. They did actually eventually deploy.
This was the Pulse server bringing down the providers, then they evaluated the expression, evaluated, and gave you your cupcakes. Sorry.
Got the IIS. And
Just wanted to show it happened.
It actually happened. We weren't lying. That's right. All right, one last thing on our way out the door. So where are we at? With desired state configuration, we've dramatically simplified the way you specify configuration, right? We've deployed a website with like this many lines of code. We've actually deployed a couple of VMs with like this many lines of code. We've integrated, and we were able to do that. This is actually, I want to hit the ecosystem. We're actually able to do that because we're layered over this ecosystem we've created, and we're plugged into other people's ecosystem, both the tool side and also the overall PowerShell ecosystem on the commands. We've enabled continuous deployment by, or we've at least encouraged a less error-prone way of continuous deployment by separating not just the idempotent automation from the configuration, but even in the configuration, the structural configuration, which is whether I have an IIS server or not, from how many servers I have, from the stuff that's environmental that would change as you go from development into production and so forth as you follow that path. And last but not least, we've actually shown that when screw-ups happen, and they have, you can recreate things pretty quickly. You just rerun it, the system rebuilds itself. We get rid of configuration drift even in our own little demo systems.
Indeed. And I wanted to point out that, I started this talk with the description of the Monad Manifesto. The Monad Manifesto was written in 2002, so 11 years ago, and the work had started a year before that. And really, we're kind of beginning this is not the end of PowerShell, but rather the end of the beginning of PowerShell. You'll see this continue on, etc. But the point I want to make here is that there are very few companies in the world that are like Microsoft. And we like to say is we play long ball, right? We take big, bold bets that often take many, many releases to bear fruit. And I think this is an excellent example of it. And you've seen PowerShell to start and grow, and now it's pervasive everywhere. And you'll see the same thing now with desired state configuration. Microsoft's in it for the long haul. Obviously, you've been betting on Microsoft technologies, and that's a good bet. We're going to do well.
We'll keep delivering.
So, well, thank you.
Thank you. You should fill out.